So example 19 is going to use Newton's law of cooling, which I've got typed up here, and you can go through and read that while I copy down the formula. Remember, all the different subscripts on the T mean different things. And this is cooling because the K up here is negative. If the K would have been positive, it would have been warming up. So the initial temperature, and it says an object cools from 180 to 150. So the initial temperature is going to be 180. And then it cools to 150 in 20 minutes. So that's a point that we know. In 20 minutes I go down to 150, and I can use that to help solve for K. And then it says that the surrounding temperature is 60 degrees, so that's my medium. So what you're going to do here is, in there is going to go this difference. So when I subtract those, I get 120. And then this formula here then becomes T is equal to 60 plus 120 e to the negative kt. So I've got my formula. Problem is I've got two unknowns, so I'm going to then use this point. I know in 20 minutes it goes to 150, where T is 20, the temperature is 150, and we're going to substitute that in there. So I'm going to have 150 for my T, 60, 120 e to the negative 20 for my T, K. So I'm going to solve this just like I did before, but I'm going to subtract 60 from both sides, and in doing that I'm going to have 90 equal to 120 e to the negative 20k. Now just like before, I'm going to get the e term all by itself. So when you reduce these fractions, you're going to get 3/4 is equal to e to the negative 20k, or 0.75 is equal to e to the negative 20k. Now the trick that we showed before, you're going to ln both sides, because the ln is the inverse of an e, so they'll cancel, and you're going to end up with negative 20k equal to the ln of 0.75. So you're going to divide by negative 20k, and that's going to give you your k value. So in the calculator, I'm going to put the ln of 0.75, and I'm going to divide that by negative 20. So I'm getting a 0.014, basically 4. So we're going to then take that k value, and I've got everything for this formula now. So to calculate my temperature, I take the medium, which was 60, and this was 120 e to the negative, and our k was got a peak, 0.0144. So now that I've got an equation that models how the temperature is decreasing, they want to know what will the temperature be at the end of an hour. So 1 hour is 60 minutes, so they want me to substitute that in there. So my temperature at the end of 1 hour I can plug that into the calculator. So I have 60 plus 120 e to the negative, that k value I found, times 60. So in an hour, my temperature is going to be about 110.6 degrees. So that's example number 19 from your textbook when you go through and solve that.